REMCOM's XF electromagnetic simulation provides the ability to view the mesh geometry in 2 dimensions or 3 dimensions. Good mesh viewing is important to verifying your model before simulation. We'll also look at XACT meshing, which is used for curved and rounded parts for accurate and efficient simulation. The first example will look at the inside of a human head model using 2-dimensional cut planes. The second example will use mesh cropping to look at the 3-dimensional mesh inside of a printed circuit board. Here we're looking at a voxel model of a human head surrounded by a bird cage used in the modeling of MRI designs. We want to make sure that the mesh of the brain is properly connected to the spinal cord. Let's turn on the mesh view and a 2D cut plane. We're also going to cut away the geometry view on one side of the cut plane so that we can see the simulation mesh inside of the model. We can slice through the geometry until we get to the point of interest. Let's change our view to profile and turn off the part's visibility. Here we can turn on mesh information to verify our materials. "2D cut planes can slice along any of the 3 principal geometric axes. Now let's take mesh viewing from 2D to 3D. Here we have a multi-layer printed circuit board and we want to check the mesh of a signal trace. We would like to see the meshing on the vias right here on these 2 traces. When we look at the 3D mesh, we can use these axes to focus only on the portion of the mesh that we want. We can also store bound selections and go to a bounds preset. Now we can set the mesh to faces with edges. To get a better view, we can make the geometry invisible. The cropped mesh still appears visible because it is selected. Turning off visibility of the light green substrate material opens up the view of the metal and vias on all sides. Now we can get a detailed view of the mesh even on internal parts such as vias. Notice that the curved surfaces of the vias and ground are represented in the XFdtd mesh. Let's stay with the theme of curved surfaces for the third example. XF accommodates curved and slanted shapes accurately and elegantly with the XACT meshing feature. This ring bandpass filter combines circular shape with rectangular features. Rectangularly oriented gridding from the XFdtd formulation creates staircase patterns along edges of curved and slanted structures. When we turn on 3D mesh, we can see this staircase pattern. The whole length of each grid cell is one material. These cell edges are conductor material and form the staircase. Let's turn on XACT meshing for this ring. We right-click on the part, we go to Gridding and Meshing, and then to Enable XACT Mesh. Now we see subdivided grid edges. XACT mesh represents the boundary of the object inside of a grid cell. With XACT invoked on a part, one grid cell edge can have more than one material. This is how XACT represents curved geometric surfaces accurately in the XF mesh. we get a different view of the exact mesh with the parts visibility turned off. We can still see the outline of the ring. For more information about meshing or XF simulation, please contact us. Thank you for using XFdtd.